class start? 2 something, right?
Class normally ends here at 5 after.
Yeah, so let's go. How about we go till quarter till? Give you some time to relax and prepare for the next one. So we got 15 minutes here of now to do some performance testing of this. So I meant to start this earlier, but here we are in the middle of writing. We've got the quick sort written, and you can in this video you can always stop and look at the pieces. There is the function quick sort. Here is the partition part taken from the pseudocode, and now here is the testing of that. There's the random function to give us an array of n random integers from the values of 0 to n using the random function. I create that array, list what's in there before I do my sort, and list what's after it's sorted. And all that does is prove that it works. Now, how do I test the performance of this particular algorithm? What would I do to tell, is it faster than another one? And it can be done even as I'm verifying that it works. I could probably, once I make a really large array, that's one hint there, how would I measure my performance? This is your chance to think about this. How do you typically measure code? And let's discuss, what are possible measurements? Yeah, the runtime. That's the first one, runtime. So what I need to do for runtime is somehow save the clock, run, and then get the second clock, and then compare. All right, let's do that. How do I get the time? So let's say time. We'll do time 1 and time 2. How about this? Time start and time end. What do I put here? How do I get the time in my system? Again, let's go back and don't be embarrassed to go look. That's your reference. Your internet is your reference manual. What gives us the time?
Something to do with date, yeah.
Yep. I'll do a quick search. I'm over here in W3 Schools. Might as well look at date formats. Do they have time? Well, let's try the date. Date milliseconds. Where's that?
I'm at JavaScript references in JS date.
Yep. So a date will give us, and is it a, how's the spelling go? Date MS or just date or what?
One of the ways they have is they have var d equals due date milliseconds, or even var d equals due date year, month, day, hours, minutes, seconds, milliseconds.
So date milliseconds. So what would I type? Date MS or
Milliseconds.
just with the word date? And then milliseconds? Like this?
In parentheses, milliseconds.
Oh. So that's actually converting a millisecond since, I think, 1970 to an actual date. So we don't want date. That's converting a value. We actually want to know what is the milliseconds. Is there some millisecond counter? Or could I get even finer? Try looking for, looks like date is not what we want, because date is giving us a date. We want something like search JavaScript system time, and there we go. That's the one we want. I just want to do a get me the time, and the time does a number representing the number of milliseconds since midnight, January 1st, 1970. There we go. We don't care about what date it is. We just want to know when I start, how many milliseconds has gone past. When I'm done, how many milliseconds is gone now. So get time is, all I want is give me a number of milliseconds. And then when I'm done, I'll have I'll be doing my sorting here, and then I'll do time end equals get time again, and then how long it took is time start minus time end. So I'll be doing a console.log duration was time start. Oh, I haven't put that in parentheses. Time start minus, actually time end is a bigger number, end minus time start. All right, now what do I do here between the time that I got my clock and the time I ended? Well, might as well do the quick sort there. So let's go ahead and quick sort my array. Before we do this, though, let's make an array a new random, because right now I'm handing it, if I do it here without doing anything else up here, I'm giving it an already sorted array. And that may be something that maybe doesn't take as long. So let's make sure that before we start keeping track of time, we do my array equals a random. And instead of 10, you know it's not going to take very long. Let's give it 1,000. And then run the quick sort, just like we did before. Oops, not there. I want to get the clock before I start the quick sort. There's where I want to put the quick sort. See how long it takes to sort 1,000 times. And you know what? Since I might be changing that 1,000, I'm going to add into there, I'm going to be telling it my array.length in parentheses, just so if I change that, I'll know how many numbers I sorted. So I'm going to be, you'll say duration parenthesis, how many numbers were in the sort, parenthesis colon, and then how long it took. Before we run this, any guess on what my milliseconds will be to sort 1,000 integers in a quick sort? Given it's a random integer array. 1,000 numbers, a pretty fast machine, I'm guessing a millisecond. I'm guessing it's going to be down in the single digits. Let's find out. Saving it. Going back to my prompt here. Let's run it. Uh-oh. Get time. I thought that was, did I do something wrong? Get time I thought was built in. Uh-oh. Maybe there's a library missing. D equals new date. Oh, okay. So I have. I thought there was a faster way. I could just give me the clock. I'm gonna see if there's something better than get time then. I don't want to have to create a date each time. Get time. Okay, I have to do d.getTime.
Where D is a date.
Oh, here's a better way. Let's just do date parentheses dot get time. That should do it. I don't want to create a variable. There, date dot get time. Since I see what I saw, if date is just a new date, then I can just do d dot get time. I think. I'm thinking I don't need to have the new variable. We'll find out. Or the new directive. Oh, it doesn't like that. I guess I have to do new date that time. Okay, well, I guess I'll have to do it their way. I was hoping I could get a shorthand.
Now we're going to do just
D. Well, I have to do D equals new date. And then d.getTime. I was hoping to not have to create an extra variable. I just don't like having extra variables hanging around. Create more objects. There we go. Okay, exactly like they did. Now let's make sure we don't get an error with that. I'd still get an error. Date is not defined. Well, the example. Oh, capital D. There you go. Those case-sensitive languages. There we go. 12 milliseconds. So I was almost in the single digits to sort 1,000. So now let's, for a little finer measurement and performance comparison. So if 1,000 milliseconds takes, or 1,000 numbers takes 12 milliseconds, 10,000 should be giving about 120 milliseconds. That's about 1/10 of a second. Let's make it 100,000. It should be about a second. Let's see if I should get around 1,200 milliseconds. And let's go ahead. Oh, there. Look at that. Look at that. 100,000 only took me 22 milliseconds. If I trust my date clock.
Why do we plug in 0 milliseconds?
Time start, time end. You're doing a new date.
Are you doing... Oh, you create a new date for both of them.
Yeah, because this is actually gets the date, and then I'm getting the time out of the date that got created. And let's go ahead and make it a longer number. So 100,000 was only 22 milliseconds. Well, let's add another 2 zeros. I don't think there's any limit on how long that array can be. And I'll run it again. There, we're around a second.
For how many?
For, was that a million? 10 million. Took about a second. 1.1295, 1.2 seconds. So on the area of a second in the quicksort. I'm gonna bump that down one because I want to show you something that I found out as I was playing with this. I'm gonna bump it down to 1 million. And I'm going to run it now. It should be about 100 milliseconds. Let's see if I get it. 123 milliseconds. Watch this. Now that array is sorted, I'm going to sort it again. So after it's sorted, I'm going to come down here and add a, let's go ahead and sort it again. How long do you expect it to take if I sort it again now after it's already sorted? What do you think? We'll call it time end 2. And I have to do a date equals new date, d equals new date. Any predictions? And we'll add another console.log. The time it took to do that second sort. And this will be time end 2 minus time end. So the time it took to do the second sort, actually, that's, I don't want to do that because I'm including here the time it took to create the, no, never mind. There is nothing more going on. I'm not recreating any array. Do you think it'll be longer or shorter the second time? Wouldn't you expect it to be shorter? Let's find out. I have a time end 2 after I've sorted it again after it's already sorted. Let's run it and see what I get. 116 milliseconds the first time. I have a million numbers. Uh-oh. They're already sorted and I'm not done yet, and it's been 5. I'm thinking it might take a lot longer. What in the world is going on? I'm going to Control-C this and shorten my array. Why would it take more time to sort something that's already sorted? And now I'm going to run it again. I reduce the size by an order of magnitude of 2. Ooh, duration.
Yeah, there's something else going on.
Something's wrong there. Time end 2 equals d.getTime. Time end 2 minus time end. Time end equals d.getTime. New date. Well, let's shorten that amount of time. Maybe you can't count up that high. I'm getting not a number. Uh-oh. Why would that? Let's. Am I spelling something wrong?
Time start.
Well, I'm treating the time end as my time start for this guy. Time end2 equals d.getTime.
Yeah, after the second you download it.
Oh.
Or line up.
Oh, look at that. Silly little parentheses. You'd think it would have given me an error on that line, for goodness sake. All right, now it's not giving a problem. Let's bump up our length again. So I don't have it taking forever. Ooh, look at that. Remember the recursion? Look what happens. This is one of the disadvantages of recursion. If you do it too much, you run out of stack room, because when you're calling a function, you're using up room on this thing called the stack. Now, there may be a way in code to tell it, give me a, increment my stack size, but this is a problem with recursion. We're just bumping into. If we do too much recursion, we can actually run out of stack room. There I'm getting a little better. But doesn't that bug you that after this array is sorted, the quick sort actually takes longer to sort a sorted array? You'd think it would go through once and say, hey, it's sorted, I'm done. It takes hardly any time whatsoever. So that's one thing I've noticed about the quick sort. Now, one more thing to look at. Now remember what we did here. What kind of array do we have here when we first did the sort? We have a guaranteed type of array. What kind of array is that? How would you describe this array?
What do you mean? Or what are you looking for?
See, I have an array, my array. How would you say my array is before I sort it?
It's a bunch of random numbers between.
Random number, non-sorted, completely random sorted. So what would be the expected type of array that you would want to sort? Is it going to be very close to already being sorted? Or is this a more realistic type of an array to expect when I'm sorting? It may depend on what kind of data you're dealing with in an application. Some applications may be mostly sorted, and you just have to make sure they are completely sorted. And an algorithm like this quicksort, you'd say, wait a minute, it's horrible. If it's almost sorted, it takes a horrible amount of time. Now let's make another function. Instead of random numbers, let's make the complete worst case non-sorted array. And what could that be? I guess I'll tell you. Function. What's the worst type of thing to sort, you would think, to give to a sorting algorithm?
One where everything's backwards.
Yeah, completely backwards. So let's create the function, and let's call it a reversed. And let's again give it the n elements in the array. Return array in reverse order. Now this is a fairly easy loop, so I'm going to make you write the loop. We'll let Luke write the loop. Very much similar to that other one, just slightly different. How would you, and if there's more than one answer, how would you create an array, completely reverse numbers, not even random, just if it's 1,000, it starts at 1,000, goes down to 1. I guess you're going to do some kind of for loop, but you get to decide what you're going to do with your for loop. What's the beginning value of I?
I would be.
Yeah. And the middle part would be
I is greater than 0.
Yeah. And I like my left pointing greater than all the time. But that's the same thing. I is greater than 0, and then I minus minus. And then what do you put here? Oh, before we start the loop, we have to do this, right? Var, or you did val, var, val equals empty array. And what would you put in the loop? Yeah, val, bracket. Uh-oh, what do you put here? Can't put I here now, can we? What do we put here? N. So remember, N is going to start at 1,000. So what I'm putting in the 1,000th position. What do I want to put in the 1,000th position? I don't think I want to put N here because N is not changing, just like I did before. I can't. I have to. This better be a different value each time through. We know we want to put I there because I is counting down. But what do I put here? Where does the value of I go into? What index position of my array? If I starts at N and then goes down to almost 0, what could I put right here? Remember, it has to be the value at 0 is 1,000, the value at 1 is 999, the value at 2 is 998. How do I make this come out to be 0 and then 999 and then 998 each time through the loop? What do you think?
Starting off I minus 1.
Right here. What do I put right here? You're correct. There's going to be a minus something there.
N minus I.
N minus I. There it is. So when I starts, if I is value N, this will come out to be 0. As the N gets smaller, it'll be the next one. Now here's a simpler way, and you might find other people doing this. I could probably do this. While I think I can do this. No, we don't do the while. We'll just do the for loop. There's another way to do it with the while, but I don't want to confuse you. And we want to finish with this. So now we're going to create a reversed array. Let's now create that reversed array and do this test again with a reversed array. We'll leave the test there that creates the random array. Now let's do another one that creates the reversed array. Oh, very good. I forgot to return it. And return down. All right, so the last thing to do here, we'll do this. We're going to test the new one. Here's the new one, and we'll call this time start. And before we do that, we're going to make our reversed array. So we'll call it var my reversed equals a reversed, and we'll give it 10,000. Now let's sort that. Quick sort my reversed 0 my reversed length minus 1. and do the same logging kind of thing after getting the time again, get the time end. So time start. Now we get the time end. And now time start minus time end. Sorry, time end minus time start. End time is always bigger than start time. So it's already going to do that random one. And let's see, how long is my random one? 10,000? And my reversed is also 10,000. Let's find out which is longer. You would expect the reversed one to be longer, wouldn't you? Let's find out. Oh, call stack. Size exceeded. So trying to sort the reversed one, it looks like actually it gave me worst case. I have to reduce the size of that just to see if I can get through it. Well, I got through it, and when I made it a real small array, let's make it bigger till I run out of stack size. Again, a problem with recursion. Looks like it's not taking long at all when it's reversed, but it is just taking over my stack if it gets bigger than 10,000. So it breaks at 1,000 reverse numbers, 1,000 down to, or 10,000 down to 0. It recurses way too much and breaks. Even though it looks like it went really fast, it still runs out of room. If it's, wait a minute, why is it running out of room still?
Did you save it? It doesn't look like you saved
Oh, yes, right, I did save it. There we go. So even though it looks like it didn't take much long at all on 1,000, well, anything more, I run out of stack space. So sadly, that recursion, it's limited by more something to do with the language than, or my memory in my stack, than execution time. And that's one of the measurements. And it's, I don't know how we could measure the amount of stack except knowing that when we got to 10,000, it broke. And so we have to just say, okay, we can't go more than 1,000, even though it goes really fast. It uses way too much memory. Typical of recursive algorithms. We'll stop there. Your job, think about how, or basically go through those other quick sorts or other sorting algorithms, and they give you code for most of these. I think each one gives you code. Sometimes it's different looking pseudocode than others. This guy almost looks just like JavaScript, but it's not quite JavaScript. You can actually find out, see if it actually that does look a lot like JavaScript. Maybe you could use this bare code without doing anything to it, but it's your job then to find out, again, the performance of this guy. Basically, we want to confirm the table they give us. Do these numbers compare to this chart they give you here of how the different algorithms are supposed to perform? There's a best case, worst case, and average. We're going to try to confirm. All right, we'll stop there. Do well on your server test.
They're all trained up.
Yes, I'll pray that you do well.